Hey there guys, and welcome back. And it is project update time. So I have a whole list of projects, as you can see on the thumbnail, to go over. To start off though, easiest one to update, Light obviously did not have an update on Friday. Recently I've been doing an update every other day because I've been working on it every other day, so that makes it easy. Thursday, Friday were both wonky days for me, so did not happen. I did not code on Thursday, Friday. Coded for the first time since Wednesday, this morning. I'm planning on doing another coding session this afternoon, so probably update on for a session update, a blog for Light this afternoon or after dinner, one of the two. Got to mow the lawn today, so that's going to take up a little bit of time. Otherwise, let's go ahead and get started. So we are starting off on this angle right here. I will need to, due to the size of the decoiler, switch it over to the top one halfway when we get to that one. I'm going to save that one for last though, because everything else should fit within this scene. So let's start off with the easiest one, the smallest one, and that is linear rails. So this is the linear rail project. As you may recall, this is one of two. We had two different designs that we did, and I said I was only going to do this one because the other one, parts for it seemed to be extremely difficult to get. So, as you can see, it is right here. It works kind of as expected. As you can see, there is a bit of friction in here. I'm not 100% sure what exactly is going on here. If we watch it running from the back at where it is right now with tightness, it really does not seem that tight, so it doesn't seem to be a tightness problem, and all three wheels are running, all three pulleys, they're pulleys, but bearings, rather, is the other way to call them. All three of those are moving, so it is functioning correctly. It just seems to have a bit of friction from somewhere, and honestly, it's not super terrible. It's not nearly as good as, and I pulled this over just for a second, but one of those things are LMUs, which we've talked about before. LMUs, it's, you know, not quite as good. However, the point of building one of these was A, for the experience, and B, because there are benefits with this one that we do not get from this one, usages. So again, I will refer you back to the linear rails video for more information on this stuff. Otherwise, what has happened since we last saw this? So obviously it's been a while, and I said I was waiting for a I was waiting for a project updates video to go back over it because it's such a minor thing, you know, it's just such a minor piece. I wasn't going to do a whole nother video on it. So it has been a while, but first thing that you may not remember is this disc was a lot smaller. So here we go. As you can see, I tried. So I had this disc originally, sorry, and then I tried tweaking it a little bit to this one, and I decided that at the end of the day, in between torque and getting this to spin and a couple other things, what was the other thing? I actually can't remember what the other thing is off the top of my head because it's been that long. But I decided to just go with the bigger disc. As you can see, it did not really get that much bigger this way or this way. I think it maybe got bigger like by a millimeter in both directions or something like that. So it was really, we had the room to use, so I used it. And this now works extremely well. Next thing to note is, again, I said, oh crap, I'm going to have to use M2s. You know, that's the only thing that's going to fit in here. This is my little wrench that I was talking about making for this cam right here. This eccentric disc, as we were calling it. Eccentric disc, for the record, works great. Works wonderfully. And the reason I brought up the M2s is that I finally got smart, and instead of using my M2s, one of those things, camera's going to be a little annoying. I will switch over to, one second, video input. Let me turn the autofocus back on. I don't like autofocus on because oftentimes it starts going in and out while I'm on the and it's one of those funny things where, there we go, and then it went back out. So one of those things, bad camera, unfortunately, so autofocus is gonna suck. But what I'm trying to show you, there we go. Oh, just for a second. We lose. All right, I give up. What I was going to show you is that I got pan heads. So I got pan heads with Phillip heads, screwdriver types for M2s now. Before, my biggest complaint with M2s every single time I've used them is that you sooner or later strip out the stupid hex on the button heads that I had. These pan heads with the Phillips head, I have had no problems. So I was finally stopped being stupid and finally got myself some M2s that I can actually use for projects, as opposed to avoiding them constantly because they would constantly strip out. So that is that stuff. And then the last thing to talk about are these blocks. So I went through a number of iterations with the blocks. Basically, and I don't have them numbered, so I'm going to really quick take a look. I want to say it went something like, I'm pretty sure this guy was the last guy, so something like this. And basically what happened is probably might have actually been like this. So the width had to change, the spacing on the rails had to change. I had to fix that. This was the eccentric disc mostly, back to me guessing on how much space I have on the eccentric disc. And the next thing is, if you look at the rail holder here, this held the rails the best out of all these. Unfortunately, even on this one, with where I've got it right now, we're still rubbing up a little bit on one side against the rail holder, and that's a serious problem. So a lot of this was adjusting trying to find the closest I could get to not holding the rails while still holding the rails, basically, because I need to eliminate as much plastic as possible along the tracks, because these U's, back to these are U bearings, right? So the U bearings are going to be at the top and bottom running up against the plastic. They won't be running up against the plastic so much in the middle because obviously the rail's in the middle, but along the edges they will be, and that was a problem. Again, this is about as close as I can get it, and the biggest problem is that this does not hold these rails terribly sturdy. These rails can pop out, which is a serious problem. The best case scenario is that you glue the rails into the plastic holders. That way they can't pop out. That would be the best case scenario. The next option that I think is probably what you would need to do a serious build with these is you'd probably actually have to build yourself a jig and drill and tap these, which sounds ridiculous and sounds like something you really shouldn't do. And it's one of those things. It's M5 rod, so it's super small, and again, just sounds like a nightmare to me, and I don't recommend it. But really, this whole entire cup shape that holds the rod, I do not think is reliable on an FDM printer. I don't think you can get it thin enough and rounded enough, basically. So obviously, as I always say, I do not have a super tuned printer because I have better things to do in my life. If I had a super tuned printer, maybe you could get it somewhere where it was a lot better than what I've got. I mean, I don't even think you can get it a lot better. Marginally better, I think it's the best you can get than what I have right now. And even then, I don't know that it would be great. So I think the best solution would be to drill and tap the rod and then just bolt from the outside. So get away from everything on the inside, just have an L bracket sticking out the back side, and tap the L bracket, bolt the L bracket to the rail. I think that's basically how, in a real serious build, this would need to be set up. So that is my conclusion on these guys. I mean, one of those things on a less serious build, on something that you might be doing for fun, just for example, like a little drawing bot. Although I like the little drawing bot designs, so they have a lot of the single axis, so this way and that way. These kind of drawing bots are actually pretty nifty. I really like these ones. But they also have, actually, while we're on the topic, they also have the other ones with the articulating arm that flexes this way. So you got one going this way, one flexing on this angle to get your whole entire... There's a lot of really cool drawing bots. If you haven't looked at them, go to look up drawing bots. The third type is the wall-mounted type, which is also cool. Runs on a sling basically across your wall. So pretend this is my wall, right? You got two fixed points here, And 2 fixed points here. I feel like you have a third point of contact, basically. And it's, in a way, a lot like a Delta machine, a Delta printer, where it can move around this flat wall, basically by driving 2 motors, which is pulling, I believe it's 2 motors pulling 2 chains, is how they normally do it. And I think a lot of them use the, like, blind chains. So, you know, those chains that come on blinds that you pull down and roll. I'm pretty sure most of them use those, but anyway, those are also cool designs. So, mini tangent out of the way. There's a lot of really cool designs for Drawbots, was my point of that one. And you should check it out. So, on to the next project. Next project we will be talking about is... I had talked about trying to get this done in time, but for the other video, but I didn't. This is the 6-inch ring for the capacitive sensors. Important thing I should note. So once I got this done, I found out, I said the numbers we were seeing on the capacitive sensor seems to be due to cable length, and that was because I switched from this jumper cable to this guy, and even when this guy was not looped around this loop, this little finger loop, even at that point it was already at higher numbers, higher capacitance numbers is what I'll call them. I actually don't know what its unit is specifically coming off the serial monitor, but the numbers in there were a lot higher here to here. As it turns out, this one, the big 6-inch one, actually has the same numbers as the little finger one, little 3-inch one, I guess it is. No, inch and a half. Little inch and a half one has the same numbers as the 6-inch one, which I realized is probably due to the thickness of the wire instead. So this obviously is a little jumper wire, is probably 28, 30, something in like that gauge. This is 22 gauge. So my new theory is that it's the gauge of the wire that determines those numbers. Otherwise, this works perfectly fine, and to some degree, I don't know in practice how practical it will be, but just looking at the serial monitor, you actually can tell the difference between touching, putting a or a couple fingers through, something in that range, and putting your whole hand through. You actually can see on the serial monitor a difference by, let's say, 10 to 20, or not even 10, 20 to 30, let's say 20 to 30 points between just putting a small amount of material through the ring and putting, like I said, your whole fist through. And then obviously once you grab it, then it shoots up by about 100. So that's easy to tell. So that gives you a lot of options for actually like kind of jesters, you know? So that is a really interesting one that I wanted to share with you. In terms of development on the 6-inch ring and why it wasn't done, basically, so I am... Oh no, that's this one. Okay. So the first one I did, which was... I actually... I actually don't think I have it. That's funny. I feel like I should have one more ring. So, the first one I did... I tried putting the wire in, and that's why I have this piece here. And as you can more or less kind of make out, if you look towards my fingers, my thumb, let's say, you'll see cuts in the wire. And that's because even though I was using the same exact numbers on the big one as I used on the little one, I was just having a heck of a time getting it in there. Oh, that's right. That's what happened. So I guess that would be this one. With this 1.5 inch wire, the rubber on the back side is actually sticking out a little bit, so it's actually slightly exposed. So yes, this is the first one then. This is the first one, and I basically sunk the wire further in so that it was completely enclosed. But even though this wire could kind of squeeze into place, since it's somewhat exposed, it's actually not squeezing all of it into place. When I tried to squeeze all of it into place on this first one, it started cutting into the wire. It wasn't big enough, so I expanded it a little bit. This was a failed print. Unfortunately, my printer ended up clogging up inside the heat break, which was annoying to clean out. So I had to clean that out. That's why this one failed. And then this one, what happened was I just logically offset the inside of it, and I don't know how easily it's going to be to tell, but there's actually no inside wall here, and that's because the inside wall actually broke off because it was too thin. So that brings us to the last one. Last one, I increased the inside wall thickness after, before rather, increasing the tolerances here for the wire, and now it works perfectly. So that was the development process on these guys. And one of those things, as previously stated, maybe this ring itself would not cost that much money and would be worth printing. However, anything else that would go on a machine, an arcade machine or whatever, at this scale, for the scale we're talking about, has to be out of wood or something similar, some cheaper material, because you really don't want to print, if this is 6 inches right here, right, you don't want to print a 5-inch border around this thing, let's say, a 5-inch panel to go on this thing, to accompany this thing. You don't want to print that. You probably want to do that in wood. So maybe you get away with taking this plastic insert and inserting into a slot in the wood, okay? But this is the limit of it. And even then, you might just consider, instead of using plastic altogether, you might consider just taking your time and gluing down the wire around the cutout in the wood instead. So that's my takeaway on this project. There we go. And also, I hate this thing, which is why I forgot I had it, but it would have been really good for the demo last time when I did the capacitive touch sensors, because, again, it's just there to hold stuff. So I hate it because it is a pain in the royal butt to get anything into position, which is why I do not use it for electronics anymore. I got it for holding electronic parts together. It was the worst investment. Well, it may be the second worst investment of my life, but we'll leave that for later to find out. I may or may not have made a serious error yesterday in terms of spending money. But again, hopefully I'll be able to laugh at that come Monday or at the latest on Wednesday. If I come here crying on Wednesday, well, you'll get to hear that story. Alright, next one up is Flight Stick. So, Flight Stick, you may notice, does not look like it did last time we talked. It went through quite a few iterations, but it does in fact work. However, we have some issues. So, first major thing that I did, and let me go ahead and pull up the CAD so that I can reference back to it. I will attempt to talk as I'm doing this. So, first major thing I did was I decided that these buttons were not pressy enough, so I added springs behind them. Now, unfortunately, the way this goes together, it's actually quite difficult to get the spring underneath this one, and the spring actually, as this is right now, is not there. So this actually just feels like a regular old controller button that you would find in any old joystick. That's all it feels like, because that's all it is. It's just the button pressing the momentary switch, which again is what you normally have in joysticks. Unfortunately, that's how it is. I'm at this point for this demonstration not going to take it apart and fix it because we have other issues. I do have a spring also placed into the back of the trigger, which again I will show you when I get the CAD open when we swap over to the CAD. And again, for the same exact reason, the micro switch was not given, actually not for the same reason. The micro switch just plain was not resetting. Again, I'm using the smaller micro switch on this guy because of room constraints, and this got a lot worse when we changed shape here. So when we changed shape here, this got significantly harder for the micro switch to fit. I added in the spring. The spring now fixes that problem, and it doesn't feel terrible. Maybe I might like a little bit more pull on it, but that may just be asking more than I need to. You may notice that I've got a gap here. It doesn't look bad at all from the back. You know, the back seam actually looks great, but I do have a bit of gap in the top, and that is because the stupid threaded insert broke out of this. Now, these threaded inserts I've used in wood, and they work just fine. And I feel like I've used them in plastic. Actually, the front you can actually see too is also pretty bad. So I've used them in plastic, I think, once or twice, but frankly, I don't know if I'm going to keep on going back to them. The fact of the matter is that they don't save me that much space, and we don't necessarily need the space on this side for the thread inserts. We could, in theory, put in captured nuts instead. So I am on the fence about doing that. It does complicate things a little bit, but I am considering swapping this over to captured nuts instead of thread inserts. Just because, again, this bad experience right here with the thread insert stripping out. And not only stripping out, but also cross-threading in the process, which was seriously annoying on here. So, again, I don't use them that often, so partially user error, I assume. But, it is just an annoyance, and I don't have that many problems with, with captured nuts. So, we may just go back to captured nuts. I don't know. Still up in the air. So, before we head back to the cab, let's look at the iterations on the handle itself. So, here we go. Let me try to get this in camera. There we go. So, this was our original iteration, and I think I might have even shown this on camera last time we were working on the joystick, when we were doing the buttons on the joystick. And again, this one, the thumb position, as you can see, is just too far up. The trigger position, according to the trigger position. So if I move my thumb down to where it feels nice on the buttons, then the trigger is too high. So shrunk it down a bit, so it's a bit more compact. Thumb buttons, trigger buttons. And actually, you know what? I think we might have talked about this one too. I might have talked about this one too in that same exact video. So you probably already know about this one. Trigger guard, decided to ditch it, got rid of it completely, and shrunk it down a little bit more. So this was the next one. Everything was decent. I think it was just the trigger was maybe a little misplaced, was my only problem. I can't think of anything else off the top of my head on this guy. Everything seemed about right. And then, as you can see, there wasn't much of a change between these two. It looks like I just shrunk it down a little bit more. Shrunk everything down a little bit more. And the trigger position, let's see. Alright, trigger position actually looks about the same place. So, actually, I'm looking at this. I'm trying to figure out what exactly I changed here, because it's actually a little bit difficult for me to tell. Alright, anyway. Maybe it might have been, let's see. It feels about the same grip. Alright, actually could not tell you at this point, because we are on iteration number 14, it looks like, on this guy, according to the CAD. So, one of those things. Not entirely sure. And now we'll swap over to CAD. Actually, let me open up one more version of it, a much older version. So I have two versions open right now, and let me open up a good bit older version, just for comparison's sake. All right, there we go. All right, and now over to CAD. Fusion Desktop. There we go. Alright, so this was the last of the big nose versions. I did like the big nose shape, but it ended up going away as we iterated. I also ended up not changing this. So this was the last version with the trigger guard, I do believe. So when we got rid of this trigger guard, I ended up just changing the trigger too, but I kind of like this wavy version on the trigger. It was nice. I also like the nose, like I said, but things had to change. Things needed to move around, so they got swapped out. This is version 6. As you can see, by version 11, this is where we're at. And the biggest problem with okay, so updating. As I updated through these things, and I kind of wish I didn't close that previous version, but the shelling process was a serious issue going between versions. And on this one, let's see. Okay, I didn't do it on this one, but on particular versions, what I actually ended up doing was shelling it, the right half. Yeah, okay, the right half I deleted, and then I mirrored the left half over the right half, because even though these halves are identical up to this point, so if we scroll here on this guy, let us do that. And we can turn the buttons off because the buttons are not actually here. So the two halves are exactly identical. As you can see, they only have this one hole which is shared between them and no other holes, right? I don't do the holes till later. So these are identical, and I even made sure that they are identical at this point by not deleting this part, so just hiding this part, mirroring this guy over this frame, this plane rather, which is our split plane. It should not have joined, but point being is that I then take that half that I created and combine it with the other half in both directions. So bodies right side with left side copy, combine in that direction, and combine left side copy with right side. Try both of those, and they both produce no bodies as a result, which means that they are both identical. So the mirror of this is identical, but the left hand side was shelling out just fine and the right side was not, which was really weird. So that was the first major headache with this. Now, holding down the Control Z button, when we got to this small size here, as you can see, things got much more cramped in here. So the next thing that had to change were these button plates. So this one, as you can see, the micro switch plate got way slimmed down. It's the bare minimum that we needed to, and it got changed a bit in the next couple of versions. But that was a necessity. The other thing that needed to happen is this plate, the button plate itself, need to move back. So this is moved back from where it was. As you can see, we got a bit of a gap here between the micro switches and the buttons. But on the first version, that I printed out, that was more or less this shape. When I finally started checking the buttons, the button plate was right up against the buttons, and we had no throw at all on the buttons. So they actually were not resetting even. I think they were actually half pressed, I think is where they were at. That's how close they were. So that had to change. This needed to be moved back, which took up some of this space. Plus, on top of that, the whole entire container got smaller to begin with. So that is, don't save, where we were with that one, and this is the final design, or the design as of the moment, because I feel like I do want to make some changes. For example, the threaded inserts rather in here, I might want to change those out. But this is where we're at. So that is the hole for the spring to go into, and then I put this back plate here for the spring to press up against to reset the trigger. And then, as you can see, I hollowed out the buttons to get springs recessed in them. Now, as previously stated, it's really difficult. If we look here, let me actually Control Z, and then just hide this one. So as you can see, this right-hand side isn't even bolted anymore on this side, because it's literally impossible to bolt it. Once you start putting these two halves together, one of them is going to have the button plate attached to it, and the other one is going to have, in theory, the trigger attached to it. Now, I did make a little bit of mistake on that one, but it is what it is. Basically, let me address that. So the trigger, the head of the bolt for the trigger is on this side, which means that the trigger itself wants to be on this side. However, as you can see, the attachment points for the microswitch plate are on the other side. So we come here, and there's the attachments for the microplate. So really the trigger wants to be on the same side as that one. Otherwise, as you're bringing this together, you're actually fighting this spring. You're fighting to get this spring in there. At the same time, you're fighting to get the spring behind this button, because both halves are coming together at the same time, and both halves have disparate springs attached to them. So all that to be said, the changes that I think I will be making, and I do have to reprint this for another reason I will get to in just a moment, but I'm thinking about actually, instead of having this back plate split between the two, I'm thinking about actually cutting this out completely and then gluing it down afterwards. That's my idea. Just because the button plate itself is so difficult to get the second half in, that if I could cut this out and then glue this as one piece onto the one half, so just glue it on the one half, and then when it at that point, the half that has the Control Z, there we go. So this half that has the button plate on it then can just be lined up with the whole entire face. That's easier, right? That's easier to get it while it's only a half, to get all the buttons lined up. And then it can be brought together no problem. Meanwhile, this trigger really should be on the opposite side, right? As we were saying. So there we go. So in theory, I actually should move the bolt over onto this side. That way I can have the trigger and the mounting plate for this guy. Imagine this is not here right now. None of this stuff. So it would just be on this half, just the mounting plate for the micro switch and the trigger. And those are one solid unit, so that all gets assembled easily enough. And then again, when we slide everything together, nothing is interfering with each other. It just slides together and then gets bolted, and that's no problem. So that is what I'm thinking of changing. The last thing that I probably need to change is I probably need to move this bolt, maybe do 2 bolts on left and right, and just make this a sleeve, because the big problem I'm running to right now, which is why I have to actually reprint this joystick, is I said so long as I just have these 8mm of thread in here, that's no big deal. So just enough to get on there, and then it doesn't really matter. The problem is that, as you can see, I cannot screw this on there because I did not leave myself enough room on the other side to actually thread all the way through. So the threading taps are tapered, right? So I didn't actually have any room to get past the taper to the actual threads, which is the first problem. The second problem is, as you can see, maybe this would be a bit more rigid if it was actually tapped correctly, but that is kind of really ridiculous right there. So I am planning on going back over to the CAD, Fusion Desktop, extending this into a sleeve. That way I can actually have an insert that I push into here, glue in if necessary, and then that insert is tapped instead, so that makes it easier for me. And I can also leave the insert open. There's actually no reason not to leave this open right here. And if it ends up stripping out or something like that, and I need to replace it, then I can just replace the insert instead of having to replace this whole entire shell. So if you imagine that I cut this out instead, then at this point I wouldn't necessarily need to replace the shell. I could just pull the insert out right now because it's not tapped, print a new one, get that tapped correctly, and then shove that in the bottom and fix it in place. And actually, to that point, so long as it's, relatively tight tolerances, I could just put some alignment features in it to keep it from twisting. So little flanges on the left and right hand side, let's say, to keep it from twisting. And that would be good enough. Then I would just press it up in there. It'd be press fit, and the flanges would stop it when I screw it onto the shaft down here. Would stop it from spinning while I'm screwing it together. So those are probably changes I'm going to have to make. Otherwise, the rest of the stick works just fine. I checked it with the multimeter. I did not plug it in just yet, but all the buttons are registering, and everything worked out good. The one thing I kind of screwed up here is I decided to see how everything looked after I wired it together and then drill the hole. And as you can see, that did not work out terribly well because I was trying to drill dead center of the crack, which was probably a bad idea. I probably should have just drilled off center here. But the fact of the matter is that now I have a good idea of what these 22 gauges look like all bundled up like this. So I can just put that hole into the CAD and not have to worry about it. Just put a hole that is about this thick into the CAD and we'll be good to go. So that was the update on the PCB joystick, flight stick rather, the arcade flight stick. And we're almost there. Again, I wish I could say that we were actually done with that one, but again, it's going to need a couple of those little modifications to make it better, to make it acceptable at any rate. So, oh, actually, there's one more thing that I should say. I'm just trying to grab a sample piece. So this is a button from before I hollowed them out, but this is what the buttons look like in case you did not notice it on the CAD. Whoops, and there it goes. I actually cut a side off of them, and you know what? Because it's black, it's probably easier to just see in CAD, so let's just do that. So you see how I cut this edge off the button? And that's because when we shrunk the head down so much, all of a sudden there was not room for the ring to go all the way around and the button was not fitting inside of the head. So that was one other change that I needed to make. You see over here, it looks like it fits on the CAD, but due to the contours of this going inwards, so because this slopes inwards towards the center, you can't actually get. So if let me just do this really quick. Grab that. Actually, I guess, shoot. There we go. This is the direction I want to move it. So if I move it here, it actually starts clipping, as you can see, the outside wall. So I actually cannot get these into position, and they cannot actually go back more than maybe this much, which is not hitting the button, as you can see, before they start clipping the wall. So that's why they need the cutout on it. And the only reason that it's all on one side is just because I copied them over. So otherwise, this guy inside of the body itself is spun around so that the flat side is towards the outside wall. This guy doesn't actually matter, but one of those things with the copy components button, everything is forward propagated. So I did not bother fixing that. And there we go. So, we are moving on to the Coiler Decoiler, but because I have the camera down here, I will start talking with the gearbox first. So, I have mentioned a number of times that this gearbox is the biggest problem with the Coiler Decoiler. That is 99% done, and this gearbox is the problem. And this gearbox, it was smaller before, and then I made it bigger to start adding some more gears, some more intermediary gears, because it was stalling out. So this is our output shaft right here. So this is maybe, well, it's an 8mm shaft, right? And then I'm guessing maybe an extra 3mm, I can't remember what it actually is, on the diameter of the 2GT pulley, okay? So let's say the 2GT pulley is like 11mm diameter. Well, I'm taking this 11mm diameter 1-to-1 up to another pulley, but then that pulley is then attached to the, let me just grab one of these, right? So we're going from the 11mm in the center here all the way out to whatever this is, which looks like 75-ish millimeters, okay, out to out on the inside here. So we're going from 11 to 75, which is a 7 times, change, 7 times ratio ish, I guess, math on stream, one of those things. So that is a lot of torque, and unfortunately that actually ends up stalling out this motor. And furthermore, after I added the one extra gear, it's at the point where it's not just stalling out up here, but I can actually slow it down on the output gear here, the green output gear. I can slow it down on the green output gear to the point that it stalls out after it slows down. So I am stuck on it, honestly. I think so. Part of it obviously is that I'm using this little 5-volt motor, again, just taken out of an airsoft gun. I'm pretty sure is where it came from originally. So part of it is just that it does not have that much torque to begin with, and I'm just asking too much of it. I think part of it, the other bit, kind of feels like there might be a little too much friction in here. I'm not really too convinced that I'm going to get anywhere meaningful attempting to remove that. So I am stuck for the time being and am investigating other options, including getting a different motor and maybe going to a different type of gearbox. But it's one of those things. If I get another motor, then I might just try this gearbox out with the other motor, see if the other motor just has enough torque. The other motor, unfortunately, would be a higher voltage motor from what I'm seeing, which is annoying because I was hoping to run all this just off the Arduino power supply. So, I mean, not necessarily. Well, yeah, actually, I take that back. Yes, it was just off the Arduino power supply. That's right. I wasn't actually using a MOSFET to begin with. But I would have to, obviously throw a MOSFET in here, have a second power supply to power the higher voltage motor, and go from there, which is annoying, but that's just where we're at right now because due to the size difference right here, the torque's too high. The torque's too darn high, even with all these reductions right here. This right here, each of these is a 4-to-1. So 416. I don't know, math on stream. It's a lot. It's a lot of reductions, and the motor just cannot maintain its speed well enough because again, it stalls out. It ends up slowing down and stalling out at this point. So it's actually not maintaining enough speed to make up for the torque in the system. But let's talk about everything else that went wrong with the gearbox. Alright, so this was my first idea, which was here's the gearbox. It looks just like the other one, obviously, but it's printed a bit differently. It's printed in 2 pieces, and this was because I wanted some adjustability. Now, I forgot to get adjustability up and down as well, and left to right. Those were the 2 areas that I decided that I should have added adjustability to because everything was not quite lining up on this design. But then I said to myself, you know what? I'm only off by a little bit actually in this direction, in the left-right direction. So I'll just fix that. And instead of printing it all like this, so in a bunch of different pieces and then having to assemble it, and this, because of this cutout right here for the adjustment there, has to be printed like this, instead printed up and down like this. So that's annoying and not optimal. So I printed another one, and on this one, the left and right spacing between the gears was off. So I had to junk that and print another one. And then I ended up printing a 4th one for reasons. This one, so the difference between the 3rd and the 4th one was, I think it was actually the motor mount. No, it wasn't the motor mount. Not the motor mount on this one. This one was, let's see. I actually do not remember what the problem was between 3 and 4. I just recall there being a problem, which brought us up to the 4th one. The 4th one, I cross-threaded this nut in here, which completely ruined it because, as you can see, well, first off, this, is a problem. These bolts need to be in the back, and I just ended up printing a 5th one. So that was a problem. The 5th one, sorry. The reason to print these next 2, this was the one that I, as you can see, decided I needed more torque and therefore more gears. So I made it bigger to accommodate more gears. So that was that one. So, one of these deals where I could have stuck with my original idea of just adding tolerances into here and making this adjustable some way. That was a possibility, and instead I ended up printing a whole bunch of extra pieces. So that was frustrating. And then we get to the fun part, which is these guys. So, Let me get that out of here. There we go. Originally, I was talking about doing rubber bands, right? You will notice I have 2 of these here. As it turns out, and actually I think I still have the rubber band. Is this it? Oh no, half a second. Let me see if I still have the rubber band around. I think that's it. Okay, yeah. So, the problem with the rubber band and why we have 2 GT pulleys now is that in this application, the rubber band was actually just stretching on one side. So it was getting caught up on the other side, as you can see what I'm doing here, and just stretching on the one side. And then all of a sudden it would hit a point where it had enough force in it that all of a sudden it would really quick, do that. And on top of that, you can see a bit of stretch marks in here. So I decided that just plain was not going to work and went over to pulleys. Now with the pulleys, I have never joined these into a loop before. So I made, where did I put that? There it is. I made this little jig, okay? And I put the 2 ends together, and then I tried just pouring Loctite on it. And that did not really work. So I checked the tutorial, and I was actually halfway there. So you do that, but then you need to reinforce the back with cloth. You'll see this is cracking, and that is because this is not cloth. This is paper towel. Because, well, shop towel at any rate. Because I do not really have spare cloth around here. So I just went with what I had, and as you can see, that is not ideal because the pulley needs to bend right around the belt needs to bend around the pulleys. So it added a bit of annoyance to the system, like it did not, a little bit of hiccuping to the system, unfortunately. So when I replace this belt with another one to go onto here, I will try to hunt down some cloth to use instead, because in theory that should be flexible. This ended up, as you can see, like a rock, which causes problems. Otherwise, in theory, if this had enough torque, it wouldn't be that big of a deal, but it is what it is. So anyway, these 2 were the rubber band ones. I can't recall off the top. Oh, actually, I do know exactly what was wrong. The difference between these is the direction the teeth are going. So I needed the teeth all going in this direction, and one of these, that one, the way that I copied the gear over, or the way I moved the gear over rather, I had the teeth going in the wrong direction. So I had to scrap this one, which is why it has the X on it, and make this one to have the teeth going in the right direction. And then when I switched over to the pulley, I tried printing a pulley onto the gear. That did not work, at least not with my FDM printer. So then we had to do a couple iterations to get the size right in order to countersink the pulley into the gear. So the pulley just goes straight into the gear and then gets locked in with the set screw through the gear itself. So that works, but no real buts. It works. And now we have a metal pulley instead of this plastic pulley that got absolutely destroyed. So that's where we're at. So that is everything on the gearbox, the thing that has given me the most trouble out of absolutely everything. The only thing that can come close to this gearbox is obviously the Stream Deck. So, and now at this point, I will kick you back over to CAD. Sorry, I walked away there. At this point, I will kick you back over to CAD just to have something to stare at while I change the camera over so that you can see the rest of the assembly. Fusion. Boop-a-doo. Camera up. Let's see where it's at. Preview, please. Get forward a little bit. Yeah, no, that's about right. Just pivot a little bit. And yep, that looks about good. So now just got to bring the rest of the assembly over. Give me half a second. Alrighty. So, and push to live. There we go. So, I found this scrap of wood in the pile at work, gave it a quick sanding, didn't do anything else to make it look extra pretty, but then mounted all the stuff to it. So this over here is our encoder, as you can see. As I previously stated, one of those things, all you really got to do is have flanges to it, and it's easy to mount. I made up these, let's tilt that this way, made up these little flanges to hold the coiler in place. Otherwise, the coiler, let's spin around to the other side, looks exactly as you should recognize it if you recall from when we designed it. Move it forwards. There we go. So that's how the coiler works. The only changes to the coiler that I made, two changes. So first off, and it actually looks like this collar's loose over here, unfortunately, but that's not that big of a deal. First off, you will notice that there's no plastic on top here. I realized that it makes my life a lot easier to just be able to pop this out to change out the coil. So that's one thing that had to happen. Change that out. The next thing that had to change was, you'll recall that I said I don't really know what these spokes need to be at what angle. So I had them at my best guess, which was more or less stretching the limits of it. And basically, as I tightened this down, this mechanism down to tighten on the inside here, they actually started slipping. They actually ended up going too much vertical and then slipping past. So all I did was just extend those legs out a little bit in the CAD. What it looks like is that it's, I'm going to attempt to pull this open as I speak. It basically just looks like they're at more of an angle in the CAD, is all that the CAD looks like. Otherwise, it looks exactly the same. And at this point, this does work extremely well. I was a little skeptical, especially once they started slipping in the previous version. I was a little concerned that there was just too much flex in the plastic, and it wasn't going to hold the coiler well enough, and therefore this whole entire thing would spin on the inside here. So this mechanism would spin on the inside of this guy. But that actually, it's surprisingly sturdy. It actually, I've put a good amount of torque onto the thing, and I have not had it slip on the inside here. So if we hop over to CAD once again, here we go. I never bothered to print out the handle, for the record, because I wanted to motorize this. So that was just an extra feature that I did not add. But as I said, the only thing that looks like it changed is, and one of those things, Fusion does not auto update the movement, the alignment features. So as you can see, if you look at this angle right here, between this hole and that hole, that's where it used to be, and now it's just out further, it looks like, on the CAD. Otherwise, these are right in line with these holes. So it just looks like in the CAD that we changed the angle, but the effect of changing the angle is that these legs get longer. And like I said, now that it was a very minor change, the only thing I had to reprint was these links, which was nice. So that was a very simple fix that I was very happy to get done. That I was very happy that it worked out, rather, as easy as it did. The other thing that I did was I made this a little bit bigger for two reasons. The encoder, I forgot to mention. So on my original encoder that I basically stole this design off of, when I did that one, I'm pretty sure I only made it about yay wide, basically just a little bit, maybe 2 or 3 millimeters right here in front of the wheel was all I did last time, and it worked just fine. But I was finding that the wheel, for some reason, at this point, was scraping up against this wall. So I went ahead and just put plenty of space on the inside here. And the other thing that I did was I left some extra space on the inside here. So these bearings, these 628s, 623s, 623s? I think they're 623s, yeah. The 623s have a little bit of space so they can open up. And my thought there is just for any wire cable that goes through, that allows it to ride basically between the two and get sandwiched between the two. It's not necessary, honestly. I could just put washers and force them together, and that would be perfectly okay. It wouldn't change the functionality at all. I just figured it might be a little bit better, just a hair better, to have the wire ride between the two bearings than against the bottom of the two bearings. I think actually what I was thinking, what I was thinking is that would help center it, is what I was thinking. So the wire would be centered between the two bearings instead of kind of floating between these two and needing something else to keep it centered. Because obviously if it's just against the flats here, it doesn't have anything to stop it from riding off either side. So that was definitely my idea, now that I recall. So back to camera. Otherwise, the encoder here, plenty springy. Spring works out extremely well. Works out even better than the rubber bands I had. I like that a lot better. This was a bit annoying on this side. Let me get this out of the way. And as you can see, the way I have this set up, the screw to mount this to the wood is right below the encoder. And I didn't really have anything that could get in there. So it is literally halfway out of the wood right now and just barely holding it. So that is unfortunate and something that should change in the design. I should move these screws out so that you can get to them. But it is what it is at this point. Otherwise, the microcontroller portion works perfectly as far as I can tell. Again, the only thing I cannot test at this point is the motor output. So I can't test the motor output to make sure that the Arduino is actually driving as much as it should be. But beyond that, the menu features work. Having the controller respond to hitting a specific distance on the encoder works. So everything about it works. I just can't test the motor at this point, which is why I can't finish the project. So that unfortunately is where we're stuck at. It's just waiting on a motor that can actually drive this giant wheel right here. And yep, that is everything. So anything else that I want to add on to the end of this video? I don't think so. As I said at the beginning, expect more light-like. That's for the time being going to be a very regular occurrence on this stream, on this channel, just because it is a relatively simple to invest the time into with meaningful returns. So I invest an hour of coding in there, and then it shows, you get to see a decent amount of progress with each 2-hour segment, each 2-hour session in the project. So that is definitely a regular. Otherwise, because the flight stick is effectively done, I will be moving on to another project. I'm just not entirely sure which one it's going to be. I think it might be the capacitive touch sensors for the arcade stick, for specifically light-like. That seems like the most logical next step, is to get those set up. So we may just go ahead and do that on the next stream, next design stream. Otherwise, I got to look at my list again. I got a list of things that I can do and see what stands out to me. Off the top of my head, I'm not thinking of anything specifically. So that is it from me. If you have been watching, thank you. And as always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.